So we start by trying to solve this like a quadratic equation, which means we have to make one side equal to 0. When I'm moving things over, in this case, I'm going to move the 1 over. We don't switch the inequality sign. Remember, for inequalities, you have to flip the sign if you multiply or divide by a negative, but not if you add or subtract. In this case, I just subtracted 1 on both sides to move the 1 over to the other side. I always move things over to the side so my x squared is positive. I find that makes it easier to factor or easier to use formulas. Because it was less than 1 to begin with. And so then when I move the 1 over, it still stays less than. But now the equation is less than 0. Let's just do a quick check to see if this one factors. It would have to be 3x and x to get 3x squared. In order to get 1, it would have to be 1 and 1. Does my outside and inside ever make 2? I make that plus and this one minus. Do a quick FOIL to check. Perfect. It works. So when we solve this like a quadratic equation, we get the solutions of -1 and 1/3. Those are our critical values, our x-intercepts, our zeros, our roots, our solutions. Did I miss any? I think I got them all. So now to figure out the solution, this is how it works using the graph. We know from our graph that -1 and 1/3 would be our two x-intercepts. Which way does this parabola go? Does it open up or open down? It opens up because the a value is positive. So just a quick sketch. This isn't a perfect sketch. We don't have to find out where the vertex is. The graph looks like that. What are we looking for? We are looking for, since I graphed this, that's my y, I'm looking for y less than 0. Can you see on our graph that that is this part? That's where my y values are less than 0. So now we can write the solution. I'm going to write the solution in a couple of different ways, just so that you can get familiar with different solutions. Sometimes the solution is written on a number line. On a number line, you would write, here's 0, here's -1, here's 1. You would put an open circle at -1 because it's not included, and an open circle at 1/3. And then somehow make it darker or shade in between, because that's the section that is true. That's writing your solution as a number line. Your solution can also be written as an interval. So solution type number 1, solution type number 2, we would say that x is between -1 and 1/3. Since there's no equal sign under the inequality in the question, there would be no equal sign in the solution. Or you can write this as an interval. And as an interval, you start with your smallest value, which is -1. And you go to your largest value, which is 1/3. And we use round brackets with less than or greater than without the equal sign. If there was an equal sign, we would use square brackets. And we'll see that in the next question. Questions you can do for this one? Are 4, 5, and 6. For looking at the test points, I generally like to go to the graph more often, because once you see the graph, it's really obvious. It's really obvious that this bottom part is where the y values are less than or equal to 0. The way that the test points work is, say you forgot how to graph completely. You knew that those were your two x-intercepts, but you didn't know if it was opening up or opening down. So what you would do is you would say, here's my number line. I know that -1 and 1/3 were my two critical values. What I want to find out is whether or not each of these sections makes the inequality true or false. And this test values is a very important technique because it comes up a lot when you do take calculus either in university or in grade 12. So what we do is we try a number less than -1. We try this first section. What would be any number less than -1? Yeah. -30. Great. You're going to really test my mental math skills. Okay. If I plug in -30 into my equation, okay, can you see that -30 squared is going to be 900 times by 3 is 2700 plus 2 times -30, which will be plus -60. So now I'm at 2670 minus 1 is 2669. Wow. Is that less than 0? No. You could probably tell already as soon as you did 30 squared, -30 squared, and got a huge positive number, that your answer would be a positive number, because no matter how much, if you subtract a little number and subtract 1, you're not going to get less than 0. So plugging in -30 gives us a big positive number, which is not less than 0. So we've used a test point, and we found out that this section was false. It is not less than 0. You could have also used your factored part, and I like to use the factored part because what it does here is if I plug in -30, will this first bracket be a positive number or a negative number? Don't tell me what it is, just is it a positive or negative? -30 times 3 minus 1? Negative. That section would be negative. What if I plug in -30 here? Negative number. What happens when you multiply a negative number times a negative number?
You may get a positive.
You get a positive number. Is a positive number less than 0? No. That also tells us this section is false. Let's try 0, because 0 is in our next section. It's a nice number to use. If you go into the original question, what happens when you plug in 0 for x? You get -1. Is -1 less than 0?
Yep.
True. So we can put a true section in there. Using the factored part, this would be negative. This would be positive when I plug in 0. And negative times a positive?
It's
Negative. And so that would also tell us that section is true. And if you tried a number bigger than 1/3, what is a number bigger than 1/3? 5. If you plug in 5, you're going to get 3 times 5 squared, which is 75, plus 10 is 85, minus 1 is 84. Is that test point less than 0? No. You would find out this section would also be false. So you'd be able to say that our solution is this part. I find that the graph tells us all of that very quickly, doesn't it? And so it makes it a little bit easier. When you do get into calculus, though, we're going to sometimes be dealing with graphs you can't do quickly. Then these test values will be very important. So it's good to be able to show both and understand how both work.